What's up guys, welcome to today's show. So today we're going to code our own ping. So ping is a program which sends a packet to another computer on the internet, and it receives a packet back, and that will test the connection like this. So here I sent 5 packets and I got 5 packets back, and in that way I know that the connection works. So this looks a little bit differently in Windows, like here, and in Linux it looks something like this. Pretty similar. But I like how the Cisco routers do the ping, because it's pretty, well, it's not very bloated. So if I log into one of my Cisco devices, I'm logging into my core router. And this is a Cisco CSR, which it says right here, but it looks the same on every Cisco device. So let's say I ping the same IP address. As you can see, it sends one of these, or it prints one of these exclamation points if the packet was successful. However, if we were to ping something which is not there, then we can see that it sends 1 packet per second, and it, in this case, does not receive any back, so it times out, and that is shown by a dot like this. So these are the only thing I want to print. And how do we do this? Well, I want to do this really low level. I want to create something which is called a raw IP socket, which basically means that my program will receive every IP packet on the network, the local area network basically. And then I will filter out everything which is not interesting. That is my intention anyway, and there's a really good man page. If you do man7 raw, then you get this Linux IPv4 raw sockets API. And it's rather easy actually. You just call this socket to create one, and then you get a file descriptor back. So you say AF inet sock stream, and then you can optionally define a protocol. So let's say I want to have TCP packets. Then I put the protocol number for TCP here, and it will filter, so we only get TCP packets. But I want to get all packets and then do the filtering myself. So that's a general idea, and then you can use the send message function, which looks like this. So you pass it the socket file descriptor that you just got, then you send the message. This is the whole packet, including IP headers and everything. And then you can optionally specify some flags. All right, so let's start this the same way as I usually do. I go to my TMP directory and I use bash bs, which is my program for just creating a template, so I don't have to code everything from scratch every time. And you can find this at the repo in bash bs. I also have an entire episode dedicated to that, which is called creating a build system or something like that. Alright, so I'm just going to call this project ping. Oh, I'm on the wrong machine, that's right. Let's go back to Intel 32. And this screen. And bash bs ping, and I want to select the default C template. So now I have a ping directory, which I am going to set to my home. And by the way, I have never used raw socket before. I have used a lot of TCP sockets and some UDP, but never any raw sockets. So let's figure this out together. Alright, so I'll go to this ping and open in editor. That way I will be able to remotely code this thing against my Linux machine that I'm using. But I think this will be rather portable actually, so you can probably run it inside of your Windows machine. Okay, so now we have these files, and you might, depending on your version, I'm gonna set this to C23. You can keep it at C2X if you don't have the latest GCC version. And if that doesn't work either, just remove this std parameter. And then we have ping.c, which is basically nothing. And then ping.h, which just includes my birch utils, which you also find in the repo. Just a couple of utility functions that I use quite a lot. And then you have some type definitions for different integers, and you have macros for casting. But I'm going to change these to, so this is 1 byte, 2 byte, 4 byte, 8 bytes. Like so. Okay, so what is a ping? Ping is an ICMP packet. So it sends an ICMP 0, I think, which is ping, and it receives back an ICMP 8, which is ping reply. And the real names for these are echo and echo reply, I think. But usually it's called ping. So we need to figure out how to create one of these ICMP packets first and foremost. So let's consult Wikipedia. If we search for ICMP and wiki, and we go here, and we go to the details. Here we see what it is. It's not that complicated. Let's make it a little bit, okay, it doesn't really fit, but okay, so we have a type field, a code field, a checksum, and the checksum is just some mathematical formula to see if the packet has been broken on the way to the computer. And then we have the rest of the stuff. So this is depending on the type of ICMP. So let's check this list. Okay, I've got it mixed up. 8 is the echo request. So this is the ping. So ICMP 8 is the ping, and ICMP 0 is the ping reply. And we set the type field to this. And the code field we set to 0 for the echo reply. And for the ping, we set it to 0 also. So this will be 0. This will be either 0 or 8. And what else? Let's see the rest of the header. What do we put in there? Mm. I actually think, let's see. I think we can put whatever inside of there actually. This page doesn't talk a lot about the echo, but I think so. So let's try that. And as we can see, this is, so one of these lines are 32 bits, so 4 bytes. So we have a 4-byte header, and then we have the rest of the packet. So let's make it easy to make this 4 bytes also. And here we can just put the word ping or something. So let's create a data structure for our ping. And there are those, what's this now? Oh, I have an old project here. Let's close this down. I was experimenting a little bit with ARM assembly. So there is already some implemented ICMP data types and stuff, but I want to create my own with only the bare essentials. So let's create a struct. Let's call it S. Well, let's say ICMP. Maybe we want to add more ICMP messages later. Okay, so what do we have here? First we have a 8-bit type field. So int 8 type. Then we have an 8-bit code field. And then the checksum, which is 16 bits as it seems. So int 16 checksum. And then we have the data, which is the rest here. So let's say int 8 data, and we'll leave this empty. Right, and let's do a type definition. So we have a struct SICMP, which creates a data type ICMP. Alright, so how do we create one of these things? Well, we need a constructor function. So let's say we have a ICMP, that's a data type, and let's make it a pointer, make ICMP. And we need to give it a type field, code field, a data pointer, and the length of the data pointer, so an int 16 for the length. So this will be our ICMP constructor function. So let's create this thing. So we will have an ICMP make ICMP, and int 8 type, int 8 code, int 8 star data, and an int 16 size, like so. So first we want to check that these are okay. So we need, if we don't have a data, or if the size is 0, in that case we want to return an error. and we'll cast this as an ICMP pointer and a 0. Otherwise we want to construct this thing. So let's create an int16n and an ICMP, let's say p for pointer or packet. So let's calculate the size first. So the size is going to be equal to the size of the structure, so struct s ICMP, plus the size, so the size of the data. And then we set p equal to ICMP like this, malloc the integer of n. If we don't have a p, we can actually even assert that we have a p. Because if we don't, if malloc fails, we are out of memory, and in that case, it's probably a good thing to halt altogether. Alright, so when we have created this thing, let's zero it out. So we'll use the zero function from birchutils, and we'll give an int8 casted p, and then we give the n for the size. So now we have an empty structure. Let's fill this out with stuff. So p type equal to type, p code is equal to code, p checksum we need to calculate. So let's say we have an ICMP checksum. That's very long. Let's just call it checksum for now. And I'm not really sure what we are going to pass this thing, but I guess we're going to pass it our packets. So let's give it p for now. And maybe we should add the data before that. So I think we have a copy function inside of birchutils, maybe not. Memory copy. Alright, we don't. Let's create a memory copy function real quick. So let's see, we'll put it down here. So we want to have a void copy, and we want to give this the destination as an int8 star, the source also an int8 star, and an int16 for the size. So this will just copy data from one place to another. So void copy int8 destination, int8 source, int16 size, and we need to have an n, and we need to have two pointers, a source pointer and a dest pointer. So let's do a for loop where we set destination pointer is equal to the destination, source pointer is equal to the source, n is equal to size. So that's where we start out, and we will loop as long as n is not 0. At each iteration we're gonna decrease n. And what we want to do in this loop is we want to set the current position of the destination pointer equal to the current position of the source pointer. And then we want these to jump to the next position. And we'll put these pluses to the right of the variable, which means that it will evaluate this line and then increase them, which suits us perfect. So now we can return. Simple enough. So before we calculate the checksum, let's copy into the P. No, let's see. We want to copy into P data, and we want to take the address of this. And we want to copy from the data specified as a parameter, and we want to copy size bytes. Then we calculate and set the checksum, and now we can safely return P. So this is our entire thing for creating one of these ICMP headers. All right. So let's see. Let's figure out this checksum. Do they talk about it inside of this thing, maybe? We'll be right. What's up, guys? Welcome back. So now I have read up a little bit about how the checksum is computed, and we're getting into that. But first, I would like to change up a few things. Instead of using one ICMP header, I'm going to use two. So my regular ICMP header will only contain the necessary fields. So I will not have the checksum here, for instance. And then I'm going to create another structure. Let's call this raw. No, not this open. Struct as raw ICMP. And this will contain the real packet. So here we have the type, the code, and the data. And the checksum. So we'll have the int16 checksum. And here I'm going to keep the data as an array. Here I'm going to change it to a pointer. So this has really nothing to do with the checksum. This is just a better way to represent it, I think. We'll see how it goes. So we don't need to typedef this one, actually. All right. I also want to add, what's it called? Well, my head is not remembering right now. But attributes, that's it. So I want to define an attribute called packed, which will be an attribute, and they are specified like this. So this is just extra metadata information that you can give functions and structures and whatnot. And in this case, I'm just going to say packed. And what packed means is that it will not align stuff. It will make them as small as humanly possible. Okay, and I want to change this. I don't want to type a code here. I just want to have, let's say I have a variable type, which is called type. Let's say kind. and then we'll define an enum. So enum e type, and I'm gonna have 2 here, but we can add more if we need to support other kinds of ICMP packet. But I want to have the echo and the echo reply. And let's also have some default value, unassigned or something. And we will create our own type for this. So enum e-type will just be type. So now we can produce this optimized structure, and then I'm gonna have a evaluate function which turns one of these into one of these, and at the same time it will calculate the checksum. So that way we can store the packets, and when we receive packets we can treat them in this kind. So it will be a lot easier, especially when we add other protocols as well. And maybe we can even make a raw packet, a raw socket library out of this. So let's define a function which is going to be called, well, it's going to return, let's see, do we want to return the structure itself, or do we want a series of bytes? I guess we want a series of bytes, actually. So let's say we have int8 star eval ICMP, and the only argument we're going to take is a pointer to an ICMP packet. And then we turn it into this structure, and then we turn it into a series of bytes. By the way, when we use this, we also need to know the size of the data portion. So let's have an int16 size here. And do we really need to know it in this case? No, since we are going to return a series of bytes, and this will only be an intermediate structure. So we don't. Okay, so now we have a little bit of better representation. So we're not going to copy anything here, and we are going to slightly change this thing, or we can keep that actually. We're going to set, let's remove all of this, it will be very different. Alright, so we're going to set p kind to the kind. So we're going to change, we're not going to take to int8 any longer. We are only going to take this kind variable. And then we are going to set the size, which is the size of the payload. So like this. And finally we'll just set the data, and now it's a pointer, so we can just set it to the data provided. Like so. And maybe we can even do something like this to indicate that we are not going to change anything. So let's update this signature make ICMP. We're going to take a type parameter, an int16 for the size, and before that we will have an int8 star for the data. Alright, and I also want to have a show function. Maybe we should divide this up by the protocol, because we're going to support a couple. So let's say this is the ICMP part, and we also want to have the show. So void show ICMP, and it takes an ICMP pointer, and this is for debugging. So we'll have a void show ICMP packet. If we don't have an ICMP, we will just return. Otherwise, we'll print some stuff. So let's see how to best do that. Let's do it like this. So yeah. So let's say kind and then we have the kind, so we can use it as a string for now, since we only have two different types, and then we will print the size of the payload, and let's print that as a regular integer like so. Then we do a new line. So this will be packet. No, it will be one of these if expressions. So if the packet kind is equal to echo, whoa, that was close. The lightning must have struck something out here. Did you hear the explosion? That's pretty cool. Alright, anyhow, so if the packet kind is echo, we want to print echo. Otherwise, let's say echo reply. And then the second argument will just be the integer version of packet size. And after this, we will have the actual payload data. And for that, I'm going to use my hex dump function from Birch Utils. Print hex, I think it's called. Isn't it? Let me just check real quick. By the way, this my code editor doesn't have that file, so that's why it doesn't show. But it takes in the okay. Maybe we should check that as well. let's do it like this. If we have a packet data field, or if it points somewhere, then we want to print hex, the packet data, and the size is packet size. And do we need a delim? I don't think so. So let's set this to 0. And then we'll just print another new line. And we're done. Okay, so now we can print this thing. Let's update the signature, by the way, for make ICMP, because we made this const. Alright, so now we can write the eval ICMP. This will be the last step of the ICMP. So we will have an int8 star eval ICMP, and we're only going to take in an ICMP packet. Same as before, we're going to check that we have a packet and also that we have a packet data. Otherwise, we return an error indicated by a 0 casted to an int8. Alright, so what do we want to return? We want to return an int8, so let's create a pointer for that. We are also gonna need a size variable for the whole thing, including the data, etc. And we're gonna need one of these structs. So struct s raw ICMP, and let's call this raw packet, like so. So we can start by filling out the fields in this raw thing. So our raw packet, it has a code and a type field. So those we need to handle inside of a switch, actually. So let's switch on the packet kind. We'll have a case for echo. We'll have a case for echo reply. And everything else we will just raise an error. So we'll just return 0 like so. And I know this break right here is not necessary. Okay, so in case of echo, we want to set the raw packet type field to 8. And the code field 0. In case of echo reply, we will set type field to 0. And the code field to 0. So those two fields are done. Then we need to say raw packet So let's see. Checksum code data and type. Is that all? Isn't there a size field of some kind? Let's go to that Wikipedia page. ICMP wiki. Type code checksum. No, that's all. Right, so let's set the checksum equal to checksum. And the only thing we need to give this is our packet. And now we're gonna copy all the bytes. So let's allocate the other thing. Maybe we can do that. Yeah, we can. Okay. Let's set the size field equal to the size of struct s raw ICMP plus the packet size, which is the size of the payload. Then we allocate this many bytes, and we can assert that we have a p. Let's also clean it out, so 0 p size. And now we should copy first the packet, the structure. So we do copy into p, and we're going to give it the address of the raw packet and the size of the struct. Like so. So now we have copied the headers. Now we need to copy the actual data as well. So we will increase p by the size of struct s raw ICMP. And now we can copy into p again. This time the packet data and the packet size. Something like this. By the way, we cannot calculate this checksum up here. Or can we? I think we need to do it down here. And I guess it's easier since we are gonna require raw bytes when we calculate the checksum. Maybe we should actually let's set this. Let's do like this. Oh, up here we set it to 0 because it needs to be 0 when we calculate the stuff. And let's define a int16 variable for the checksum. Let's call it check, since we will have a function called checksum. Which never mind. I don't think it will collide with our structure. Okay, so now we have the raw bytes. Now what? By the way, we should actually align this size to 16. Let's see, to 16-bit boundary, which means that if size mod 2 is 0, so if this is an even number, we do nothing. Maybe we can do like this then. So if it's an odd number, we increase size by 1. And now we can calculate the checksum. And this time it's going to be based on two things. Well, we increased p right here. So we need to have some variable that holds the initial value. So let's say we have a ret variable. And after the allocation, we'll set ret equal to p. So we save that thing. And then we calculate the checksum based by ret, and the size we also need to know. Okay. And now we need to put that checksum in the right place. So let's also create a struct s raw ICMP raw pointer. And this raw pointer will be pointing towards the p, but we need to cast this as a struct s raw ICMP star, and it should be the start of the byte, so ret, not p. Okay, and why do we do this? Because now if we modify raw pointer checksum, maybe we need to dereference this. Maybe not. So if we set this checksum now to something, it will change the bytes inside of ret. So now we can safely return ret with the updated checksum. That's the general idea anyway. So let's see, what did we change here? Guess we didn't change much. The eval ICMP is now taking an int 8 star instead, and a size. Alright, so how do we calculate this thing? So what we need to do is, it sounds a little bit advanced. We're gonna go through the whole packet, all the raw data, including the header and the data field. And we're gonna divide it up in 16-bit portions. And we're gonna take them 2 by 2. So let's say we have AB and then CD and so on. And we're gonna take the addition of A and B, but not a regular addition. This is something called a one complement addition. So basically we need to do an addition, but we need to save the carry. So if we have, let's say, AB plus, I don't know, 8, and I can't calculate in my head what that is, so let's do it here. AA plus, no, AB plus 88, and then we turn this back into hex. Okay, so this is the result, but we are only dealing with this is a byte example, but we're going to do the same for the 16-bit things. But let's say we have 2 bytes, A and B, and this will resolve to this, which is actually a 16-bit number, 01333. And if we're only handling bytes, what do we do with this? Well, in this case, we're going to take we're going to take the result, the 3, and we're going to plus 1. So we're going to plus this byte right here. So the result of this addition is 3,4. So then we do this by 16-bit numbers, not 8 like I did here. And then we plus all these together. And at the end we end up with a sum. And then we do the bitwise ones complement of that. So basically if we have, let's say, an 8-bit, let's say 4-bit number, let's say we have 0110. So we basically flip all the bits by the end. So this will be 1001. Okay, sounds pretty advanced, but I don't think it's too bad. Let's see the page I was looking at, by the way. This RFC 1071 shows all this stuff. Byte by byte, so 0, 1, F2, 0, 2, F5, 6. Okay, so we can actually do it like this. which makes it a little bit simpler. But because if we do it like I showed here, then we will end up with AB and with CD, and then we have to do AB plus CD, and this is pretty complicated to know which things to add together. I like this approach where we just we take all the 16-bit values and just plus them together in one go, I guess. Yeah, and just increase the sum. And if we, at the end here, when we have plussed all of them together, we just take all the overflow here and add that to the end. Okay, this is pretty simple, I think. I really like this solution. Okay, so let's see if we can actually do this thing. Let's create a signature for this operation. So we're going to return an int 16, and this is a checksum operation. And it's this that takes an int 8 star and an int 16, not the one I specified down here. The eval ICMP still just takes an ICMP pointer. Glad I caught that. Alright, so int 16 checksum. And by the way, I think we can use the same checksum for IP as well. So we don't need to develop several of these algorithms. So int 8, this is the packet, and int 16 the size. And this size is already aligned on a 16-bit boundary. So let's see. We need to have an int 16 pointer. Let's call it P. And let's say we have an A and a B value. Or rather, an accumulator. And since we are overflowing here, let's make the accumulator an int 32. Or maybe it's easier to do both. So both the B value and the accumulator will be in 32s. And we're going to need an int 16 value. I guess an int 8 actually would be enough, but just to be on the safe side, where we deal with the accumulator. No, not the accumulator, where we deal with the carry. Okay, so let's see what we need to do. We'll have a for loop. We'll set our pointer equal to the int 16 star of the packet, so the first address of the packet. And we're gonna, let's see, let's say we have an int 16n as well. So we'll set n equal to the size, p equal to this. And we're gonna loop as long as we have a positive n value. At each iteration, let's see. At each iteration, we're gonna minus n by 2. Since we are going through a series of bytes, but we are reading them 16 bits at a time, so 2 bytes at a time, then we need to decrease this n by 2. And how will we increase p? I guess we will just increase it like this, and that will jump to the next 16 bits. Let's also start with a 0 accumulator. So our b value is going to be what the pointer is currently pointing to. And then we're just gonna increase the accumulator by the b value. Yeah. So we go through and we just fold this whole thing and increase this, so we create a sum. But when we are through, we need to take care of the carry as well. So the carry is going to be the accumulator, but we are only interested in the upper 16 bits, which means we're going to AND this by FF0000. That will take the top 16 bits. And then we need to push them 16 bits to the right. So we get rid of all these zeros. And that is our carry. And then we just take the accumulator. No, we need to grab the 16 lower as well. So let's say we have an int 16 sum. Where the sum is equal to the accumulator, and this time we AND it with this. So we get the lower 16 bits, and we don't need to shift them anywhere because they're at the right place. And now we can just return sum plus the carry. No, not right, like this. We need to invert this as well. So this is what we're going to return. I think. I think it makes sense. Alright, so how do we test this thing? first of all, we need to have some string. We need to have a packet, which is of type ICMP. And we need to have the string of bytes. So raw, let's just call it raw. So first we allocate for this string, and let's say it's just the word hello. So what we'll do is we'll malloc size 5. We assert that we have a string. We zero out this string. Let's give it a null terminator so it's easier to print. And then we'll just string copy into this thing. So we'll turn this into a char. We'll copy from string hello like this, 5 bytes. Okay, so now we have the data portion of the thing. So now we can just do packet is equal to make ICMP. We provide make ICMP. We provide a kind, so let's say this is an echo packet. The data is our string. The payload size is the 5 casted to an int16. Let's assert that we have a packet like this. Let's show ICMP this packet. And now we want to set our raw equal to eval ICMP. We give it the packet. And let's assert that this is positive. And then we can print this the same way. So let's say well, we need to have a size variable as well. So the size is going to be equal to the size of a struct s raw ICMP plus the packet size. And then we can print hex this raw packet of size like this. Then we can free the packet data. We can free the actual packet, and we can return 0. Alright, this is the first time we compile this thing, so there will probably be some error tracking, but hopefully we will figure this out. So let's run it. Attribute. Maybe it's not on both sides. Maybe it's... it should be attribute, not pluralis. Assignment discards const qualifier. P data is equal to data 95. Well, we're not going to change this data inside this function, so let's just do this. Expected expression before ICMP. We should check the packet, not the data type. Alright, that's not too many errors. I hope that doesn't mean that there are a lot of other more difficult errors when we run the thing, but let's try it out. Okay, so the kind is an echo of size 5, that's right, and this is the payload. 4865, this seems like ASCII characters. Let's double check. Yes, that's a string hello. Okay, so this is the actual packet, and in order to make sense of it, I guess we need to go to the to this right here. Let's copy and let's do echo to dev null so we can have it on screen. Okay, so the first is a type field. It's 8 bits, and that is 8. Which is that is correct, yes. Code also an int 8 0, that's correct. Then we have the checksum, which is the most interesting thing, right? And that is D4 to D. And I don't know if that is right, but it's something. It looks like something it could be, right? We will not really know if this is the right checksum until we try to send this packet and see if it goes through. But everything looks like it's supposed to. So yeah, I think that will be all for today. But in the next episode we are gonna code the rest of this thing, and I hope you like this, because I think this is gonna be a really cool project, and it's always good to have code for being able to collect the packets and send packets on the level of the network interface card, really. So I hope you like this and that you like this episode, and don't forget to subscribe. Thank you for watching. Thanks for today.